In today's video, we're going to learn a process called completing the square. Completing the square is a method that can be used in order to solve a quadratic. Remember, when we solve a quadratic, what we're really asking you to do when we say find the solution is to find the x-intercepts. Now, solutions are also called roots and zeros. But the main thing is they manifest themselves as points on the x-axis that your graph crosses. You can have two solutions. You can have one solution. And you can have no real solution hitting your x-axis, but instead two imaginary solutions in that different coordinate plane we've been talking about in the imaginary numbers section. So far, this unit, we have learned how to solve quadratics by factoring, by finding square roots, aka SADMEP, reversing PEMDAS. Today we're going to do completing the square, and eventually we'll do the quadratic formula. For us to be successful, we have to do a little bit of pre-work. Now, the pre-work is actually pretty quick and easy. It's just two little steps you can see on your page. What the purpose of the pre-work is to get comfortable by making a perfect square trinomial. So, what is a perfect square trinomial? A perfect square trinomial would be any trinomial that whenever it factors, for example, x squared plus 6x plus 9, it ends up being the same factor times itself, or that factor squared. So since x squared plus 6x plus 9 factors into x plus 3 times x plus 3, or x plus 3 squared, we would call x squared plus 6x plus 9 a perfect square trinomial. The important part that we're going to focus on right now is figuring out what that number c needs to be in order to make that a perfect square trinomial. I promise we're going to use this in just a minute. So, first example. What does c need to be in order to make this expression a perfect square trinomial? How do you find that? Well, step one, you take half of the x term and square it. Remember, the x term is b when you're in standard form. You've got a is invisible 1, b is 8, and you are trying to figure out what c needs to be. So let's do just that. Take half of the x term, that's 8, cut in half is 4, and square it. Well, 4 squared would be 16. This becomes your c value. So c is 16. Now, we know we're correct on this one because if I take 16 and I put it right back there, x squared plus 8x plus 16 is in fact a perfect square trinomial. How do I know that? Well, the factors of 16 that give me the middle of 8, when I add or subtract them, would be 4 and 4. And that is the same thing times itself, x plus 4 times x plus 4, or x plus 4 squared. Okay, your turn. A little bit more. I'll do a couple more. If you want to, feel free to pause the video and try it yourself and then keep rolling the video. If not, carry on. I'll still explain them. So, the easy part. Take the middle, cut it in half. 24 divided by 2 is 12. And then square it. So the c value for this first u-try example is 144. Now, do we know that we're correct? Yes, we do. Because if I plug in that c value, I have ended up making a perfect square trinomial because x squared plus 24x plus 144 factors into x plus 12 times x plus 12. And again, of course, you could write that as x plus 12 squared. There's a reason why I'm doing that extra step of that or x plus 12 squared that you're going to see in just a minute. So what was the magic value of c? It was 144. How did I find it? I took half of the b term and I squared it. All right, here we go. The b term is negative 2. Cut it in half, so divide it by 2. That's negative 1. Square it, that's positive 1. c equals positive 1. So x squared minus 2x plus 1 is in fact a perfect square trinomial. And I know that because if I take it the extra step, that would be x minus 1 times x minus 1, or x minus 1 squared. The reason why it's a perfect square trinomial is because it is factored into the same thing times the same thing. So here we go, last example. 18 cut in half is 9. 9 squared is 81. So c would have to be 81 in order for x squared plus 18x plus 81 to be a perfect square trinomial. Now, how is this one going to factor? Take a wild guess. By now, I'm kind of hoping that you've caught on to a pattern. Every time we factored, even though we weren't asked to factor, we were just doing it because we wanted the knowledge, right? We wanted to make sure we were right. Every time we factor, did you notice that the number that you cut in half, that result, like 24 cut in half is 12? That 12 just so happened to be the number of how it factors, right? Those two terms when they factor. So that's the number that goes in there. Let's see if that's true in all of these other examples. When I took negative 2 and cut it in half, I got negative 1. When I factored, sure enough, it ended up having a negative 1. So when I'm doing 18 divided by 2 is 9, I already know that I'm going to have x plus 9 squared. That is not a coincidence. Why? Because x plus 9 times x plus 9 foils back into x squared plus 18x plus 81. So 81 may have been that magic number to turn that sucker into a perfect square trinomial, but really I need to pick up on the clue of as soon as you cut your number in half, that's going to be how it's going to factor. Okay, so that's the end of the pre-work. Now let's actually do the work. This process may look a little bit involved. It's actually not that bad. I know it's kind of 8 steps is a lot, but as soon as you do the first 2 steps, you've basically gotten half your problem finished. I know that sounds crazy because it's not what it looks like, but I promise it's going to be really quick and easy. Okay, so big important thing you need to make sure, first and foremost, always make sure a equals 1. Remember that we've got standard form, ax squared plus bx plus c equals 0. Make sure a is invisible 1. A is invisible 1, we're good to go. So that's the first step. The real first step, the actual first thing you do, you also make sure that the constant is isolated. So what's happening is right now when you look at this problem, x squared plus 16 from plus 6x minus 16, that is not a perfect square trinomial. The factors of 16, 1 and 16, 2 and 8, or 4 and 4, definitely not the same thing times the same thing to get the middle. So right now, what's going to happen is you are actually going to manipulate this problem and turn it into a perfect square trinomial. That's kind of why it's called completing the square. You're making it into a completed square. So what do? Isolate the constant. How do we do that? We move it over and we make room. When I update my problem, I'm going to put x squared plus 6x plus blank equals 16 plus blank. That might seem a little weird to have these blanks, but you're going to fill them, obviously. Why do you have two blanks, you might be wondering? Well, what you do to one side, you've got to stay balanced with the other side. So when you turn the left side into a perfect square trinomial, you have to make sure whatever you add on the left, you also counterbalance and add on the right. So step 1, make sure a equals 1. Check. Invisible 1, done. Step 2, move any value that's c already over away from the x terms, right? The x squared and the bx. And of course, build in those blanks. Step 3, what you've already done in your pre-work. Take half of the x term, square it, and add it in both of those blanks. So 6 divided by 2 is 3. 3 squared is 9. So 9 is going to go in both of those blanks. 9, 9. You got to make sure you add it to both sides, which is step 4, which is why that's kind of a silly step because we already did that. Now, step 5 isn't really even a step, it's a statement. The left side is now a perfect square trinomial. How do you know it's a perfect square trinomial? Because when you factor it, the factors of 9 that give me 6 are a positive 3 and a positive 3. So you are able to write this as the same thing times the same thing, or x plus 3 squared. So we're already to step 5, really now on to step 6, and we've barely done anything. We moved the 16 over, and we cut the middle in half and squared it, and added it to both sides. So why is this important? Because step 6 has us do this right here. And because you noticed in our pre-work that every time you take the number and you cut it in half, that little shortcut, that becomes the number that gets squared. This is a quick and easy step. So when it says factor into a binomial, this becomes x plus 3 times x plus 3, or even easier, x plus 3 squared. You want that to be with that square. You don't want to leave it in this format. You want to write it as the binomial squared. Okay, so if I update the right side, 16 plus 9 is 25. See, what I really want you to catch on to, what you've just done is you've done this really weird workaround where instead of factoring, you actually made it into a perfect square trinomial and converted it to vertex form. I'm going to recap that in a minute and really just take it back to what we did in the top. What you did is you did this process where you converted it and you made it SAD-MEPable. That is not a word, but we're going to say it's a word. So by completing the square, you chose not to factor and instead to manipulate your problem to where you were able to solve it by finding a square root. So that's exactly what you finished doing. Step 7, take the square root of both sides. So we force the square root. We have x plus 3 equals plus or minus the square root of 25 is 5. Remember that the square root and the square cancel. And we finish by solving. So remember that to get x by itself, we subtract 3. Recall from before Christmas break that you put that in front. So what are our answers? Negative 3 plus 5 is 2. And negative 3 minus 5 is negative 8. So the big picture. When I take x squared plus 6x minus 16 equals 0, and I graph it, it will cross the x-axis at positive 2, negative 8. It'll have a y-intercept of negative 16 way down there, and it'll open up like a cup because a equals positive. And you can't see my parabola, that looks terrible, but hopefully you can see that that's what's happening. Okay, let's try another one and let's make sure you get what's going on, because it looks a little daunting probably, but it's really not that bad. It's just another process you gotta get used to. All right, here we go. Step 1, make sure a equals 1. Solid, done. Step 2, kick out any constant and make room. So we have x squared minus 4x plus blank and negative 2 plus blank. Next step, take the middle, cut it in half, square it, add it to both sides. So negative 4 cut in half is negative 2. Negative 2 squared is positive 4. That's what goes in both of those blanks. What we do to one side, we got to balance and do on the other side. So we adding 4 to both sides. This has just made the left-hand side a perfect square trinomial, which can now be written as x something squared. That something being the result of when you took the middle and cut it in half. Every single time. Think about it. Negative 2 times negative 2 multiplies to be positive 4 and combines to be the middle negative 4. So it does factor into x minus 2 times x minus 2, or x minus 2 squared. The right-hand side, this guy right here, well, we've got negative 2 plus 4, so that's positive 2. What you've done is you have made this SADMAPable, again, not a word, go with it. So we're going to finish it up like SADMAP would tell us to do. We're going to square it both sides. So x minus 2 equals plus or minus the square root of 2. We're going to add 2. Protocol says put it in the front. So our final answer for this problem is 2 plus the square root of 2 and 2 minus. That's 2 different answers. It's crazy ugly decimal, but the good news is I'm not asking you to tell me that decimal because you're super allowed to leave it in this little exact form where you just leave the square root there. No problem. Okay, your turn. If you want to pause the video, go for it. If you want to just keep watching, that's fine. If you want to speed through, it's up to you. And then in a minute, we'll do the last examples of what do you do whenever a is not equal to 1. So, quick version. Here we go. You try. X squared plus 8x minus 11. We start by kicking the 11 out and making room. X squared plus 8x plus blank equals that same 11 plus blank. Cut it in half and square it. 8 cut in half is 4. 4 squared is 16. So I'm adding 16 to both of those sides. The left-hand side just became factorable. And that would be x plus 4 squared. Remember that it's always going to be the same thing as the number cut in half, the result of the number cut in half. And the right side just became 11 and 16, 27. We finish it by taking our square roots. I'm going to move that over a little bit. So I'm also going to get rid of this little, there you go. Force the square root. The square root and the square cancel, leaving you with x plus 4 equals plus or minus. The square root of 27, remember that can reduce. 27 is 9 times 3. So that would be plus or minus 3 root 3. And when we subtract 4, we put that in front of the plus or minus. So your two x-intercepts are negative 4 plus 3 root 3 and negative 4 minus 3 root 3. I'm just writing them together to save time and space. Okay. Now I also want you to notice that if any of those square roots had negatives underneath them, all that would be the difference was you pull the I out, and those are your imaginary solutions. Last two. So what do you do if A doesn't equal 1? Very easily, you take it out. In this case, example 3, A equals 4. That is not what we want. Not going to happen. Now, mathematically, why you're allowed to do this is because what you're really doing is you're dividing out the stretch. The stretch of a graph does not affect at all the x-intercepts. Crazy true. Crazy but true. So when you divide everything by 4, all you're doing is taking away the stretch. And as long as you do it to every single term, it's like taking out a common factor. Great. Perfect. Do it. So you have instead something easier to work with smaller numbers. I think that's a win-win. We've got 4 divided by 4 is 1. 32 divided by 4 is 8. And then 8 divided by 4 is 2. 0 divided by 4 is 0. Perfect. It's supposed to be 0 anyway. All right, we're good. So we divide everything by that number. Now we start doing the process. We kick the constant over. We make room and build in our blanks. What goes in the blanks? Well, 8 divided by 2 is 4. 4 squared is 16. This has enabled you to write the perfect square trinomial that you just manipulated and made happen on the left as a factored x plus 4 squared. Remember, this is not a coincidence. Every single time the number cut in half, the result of that number cut in half is going to be what goes in the binomial squared. And then we have what? 14? Negative 2 plus 16. We square root to finish it. X plus 4 equals plus or minus the square root of 14. Believe it or not, 14 does not reduce. 1 and 14, 2 and 7. Nothing is perfect other than invisible 1. And why would you take out invisible 1? So we leave the 14 because I can't do anything about it anyway. We move the 4 over by subtracting it. And our final answer is negative 4 plus and negative 4 minus the square root of 14. Aren't you glad I'm not asking you to graph those, because those decimals are nasty. All right, if you want to skip the U-try, you're more than welcome to. I'm going to wrap up at the very end in about 30 seconds. Maybe not, who knows. If you want to watch the U-try, go ahead. Here we go. We divide everything by 3 to get rid of the 3 in the front and manipulate it so a equals 1. So that leaves us with x squared minus 6x minus 1 equals 0. We kick the negative 1 out by adding it to both sides and leaving the blank. We take negative 6, we cut it in half, that's negative 3. We square it, that's positive 9. 9 is what goes in the blanks, and it allows that left side to become a perfect square trinomial, which whenever you factor it into a binomial squared, you have x minus 3. I want you to notice, especially on this one, that the minus is important. Negative 6 cut in half is negative 3. Negative 3 times negative 3 is positive 9, and negative 3 plus negative 3 is the negative 6 in the middle. You need the sign to stay there. And then that would equal 10 because you've got this 1 plus 9. We force the square root. So x minus 3 equals plus or minus the square root of 10. The square root of 10 cannot reduce 1 and 10 or 2 and 5. So we just leave it there. We add the 3. And we end up with x equals 3 plus or minus the square root of 10. Your two x-intercepts, even though they're crazy ugly decimals, they're still correct. So, tying this all together, you have 3 different forms of a parabola. We learned this in Unit 4 when we graphed parabolas in all 3 of these forms: standard form, intercept form, and vertex form. when you were converting from intercept form to standard form, all you had to do was FOIL it. When you were converting from vertex form to standard form, all you had to do was fancy foil it. And what I mean by fancy foil is you had to actually write the squared term twice and then FOIL that, distribute the A, and then add the K. Whereas here you just had to FOIL these two and then distribute the A if there was one. I think you can see that. Sorry, the page is in the way. Now, when you want to convert from standard form to intercept form, you factored it. Split it up. If you want to convert from standard form to vertex form, that is what we just did. You complete the square. So to tie this all together, on an example that we just did, when you were at this stage right here, before you finished it and solved it, you had x plus 4 squared equals 14. If you would have simply moved over the 14, you would have had x plus 4 squared minus 14 equals 0. Realizing that that is in vertex form, y equals x plus 4 squared minus 14, you'd be able to tell me that the vertex is at -4, -14. So if you were given this originally in standard form, you could have done completing the square to convert it to vertex form and then answer questions that you answered in Unit 4 already. Now, that's extra. That is not necessary, and I'm not asking you to do that. But I want you to see that there's a big picture at play here, where by being able to manipulate using mathematics, like factoring and completing the square, you can transform from one form to another, and vice versa. So, something interesting I wanted you to catch on to. All right. Thank you for sticking with this crazy long video, and I hope you're doing well. If you have any questions, always ask. We are more than happy to help you.